A problem with the integral. A solution. Please note, this is my original work, the work of A. Willis, your narrator, to address recurring and annoying problems in education. All uses of my work and future works must include citation of my work. When a person named Carl Friedrich Gauss was in what you would call middle school, the teacher issued a challenge to the class: find the sum of 100. Apparently, Gauss knew a little more than his other classmates because he came to a quick and simple answer. If Carl had rows of strings of beads, counting from 1 up to 100, then he had a triangle of 101 strings of beads. Thus, the sum of x is x times x plus 1 over 2. The sum of 100 is 100 times 101 over 2, or 101 times 50 equals 50/50. The sum of 10 is 55. The sum of 5 is 15. Do you see a problem here? Because I do. We learned that in calculus, we learned that the derivative of c times x raised to n equals c times n times x raised to n minus 1. Thus, the continuing sum of x is the inverse, x raised to n plus 1 over n plus 1. If n equals 1, then dx over dx equals 1. Thus, the integral of x equals x times x over 2. Let's try it. X equals 5. The sum of 5 is 15. The integral of 5 is 12 and a half. Huh? The integral is less than the sum. The power rule is where the tenet for raising x or f to a power emerges, and it governs the algebraic aspect of calculus. If f equals x raised to n, then df is the associated approximation sum. So if n equals 1, then df over dx is also 1. But if x equals 5, then 0 over 0 equals 1. No. This tenet goes according to the indivisibility of 0 and 1. Given that 5 factorial equals 5 times 4 times 3 times 2, which is 120, 5 factorial also equals 5 times 4 times 3 times 2 times 1, which is also 120. 5 factorial does not equal 5 times 4 times 3 times 2 times 1 times 0, which is 0. If x times 1 equals x, and x times 0 equals 0, then dx x times 1 equals x minus x times 1 equals 0. Dx times x times 0 equals x minus x times 0 equals x. This is called the binary indivisibility of binary numbers. It also means that x over x equals 1, 0 over x equals 0, x over 0 equals 0, 0 over 0 equals 0. Also, please tell me who wrote this joke, because I can't find who wrote it. This is wrong. What that means? It means that we must consider how fast dx is approaching 0, but in calculus, the rate that dx is approaching 0 is not considered. Thus, dx is considered to be infinitely small. The divisibility of binaries also applies to INF. Since INF is a function, it must be of some measurable thing, or else we have left the realm of math. Its usage: given that dx equals 0, dx raised to n equals x to the n minus x to the n over 0, which is 0. But to say that it approaches 0 means essentially INF, which is still 0. The algebraic derivative has no provable measure. Dx must have value. df equals x plus dx raised to the n minus xn all over dx. The integral of f dx equals f of df dx equals f equals x raised to the n. The textbook asserts that y equals dx to the n, not f. Calculus 1, 2, 3 is redundant. 1, 2, and 3 is redundant for these reasons and should be removed from the textbooks. The algebraic derivative function itself is derived from the power rule. In the text, d of x raised to n equals limit as dx approaches 0, and its approximation. The sum of dx leads to the hybridization n times x raised to n minus 1. Usage case. The derivative of x cubed provides these cubic residuals. which when given value produce this. If dx equals 1, 3x squared plus 3x plus 1 is 7 at x equals 1. 3 times 1 squared equals 3. From this point, the function cycles. So to get 3, dx must be 7/3. 3x squared dx given and these other residuals produce 38. Obviously not 7. If dx equals 0, 0 over 0 is 0. However, taken to the physical limit, the smallest measurable length, Planck length, which is 1.6 times 10 to the negative 38 in meters, we get approximately 3. But there is still some residual value, one value in thousands and another value in millions. Now the sum. Understanding that for sums, x can be seen as I over n. We notice that for x equals 1, n equals x inverse, which is this enormous number. So as the number of n's approaches this number, x cubed becomes I cubed over n to the fourth. The sum of I cubed over n to the fourth, or 1/4, which is what is consistent with the integral of x cubed at 1. The discrepancy. There is still some discrepancy in both the sum and the derivative of x cubed. Given that I equals x over n, the sum, the continuing sum, is b minus a over n squared times n times n plus 1 over 2, which is corresponding with what the integral is. For the interval of 0 to 5, we have 25 halves, and the sum and the interval from 1 to 5 gives us 8. So as n approaches the Planck inverse, the interval decreases. The sum approaches the integral, etc. A more dramatic example. Given that the integral from 0 to 5 of x cubed dx equals 5/4 over 4 equals 156.25, the sum of n equals 5 of x cubed is 225 by just counting all the sums up to 5, by counting up all the squares up to 5. The difference by themselves is 2.5, but when cubed it's 64.5. The example problem increases exponentially with the exponent. A novel coincidence. Given that NA is Planck inverse, the sum holds. Thus, as n increases, the sum approaches the integral. The increment should be the number of n's times the length of n. If n times the length of 1n. If n reaches 1 as n approaches Planck inverse, the sum of 5 is closer to the integral of 5 than the sum of 50 is closer to the integral of 50 by 10 times Planck. This does not hold for infinity, because then the increment would be 0, in which case you would be witnessing a perfect or impossible universe. An economic example. We have established that n approaches Planck. 1 over n raised to k plus 1 is times the sum of I raised to k is proportional to the integral of x raised to k dx. And as n approaches Planck, a approaches a0 times e raised to rt. What this means is, let's say we have two employees, A and B, that earn the same amount with interest at the end of a year. The employer wants to compile the dividends of earnings in 30ths for A and 90ths for B. That's x times 15 times 31 for A and x times 15 times 30.33 for Bn. B will make less than A exponentially. So if you plug this for a0 and do the math, and then you plug b in for a0 and then do the math, you see that a is rising faster than b exponentially. In multiple and there's a second problem in the books. In multiple textbooks, it is printed that y equals f of x. This cannot be true. It is confusing because in an axis, so is z. Thus, f becomes f of a set of x's, which contain the parallel perspectives of f. In 6 dimensions, for example, we notice that f of x squared is proportional to f of a set of x's in x, where the set of f of x's contains the set of f's for a set of x's. The derivative then becomes this for each x in f, where if the interval for the set of xi is greater than 3, then f is considered a supergraph. So for example, the derivative of f dx is proportional to the sum of all s times the derivative of the considered x, or the partial derivative of x with respect to each x. So the integral is the sum of all the x's except 1 times the integral of that x. The textbooks assert that y equals x to the n and dy over dx equals n times n x raised to n minus 1. Function f equals x to the n plus y0 plus z0, etc. Thus, df dx approximates x times n times x raised to n minus 1 as n approaches Planck. That's df of each x approximates that f times the sum of each interval of xi raised to n minus 1 as n approaches Planck. Please correct these formulas and observe that the sums in calculus are differential. Techniques used: the power rule, the Riemann sum, exponential decay. Authors featured: Larson, Hostetler, Edwards, Milton Smith, David M. Burton, and Devaney C. Blanchard Hall. Images. Thank you for hearing. It is important. This is the end. Like, subscribe, share.